Alright, so 9.5 video notes. We are looking at finding the area of all kinds of polygons. So we got pentagons, we got octagons, we got hexagons, all the gons. There's not a different formula for every one. They're basically, it's the same formula, just the number of sides changes. And there is a formula, but I want to kind of develop it before I just say, hey, here's the formula, let's do it. So let's talk vocabulary. So start filling these in with me. So the center is just like a circle. There's a center point right in there. The apothem, I kind of think of the apothem as it's kind of like a radius, but you got to know where to go to. And basically it goes from the center straight down perpendicular to a wall. Alright, so this particular shape, this hexagon, has 6 apothems because I could connect to 6 different walls all the way around. Alright, so that's the apothem, and oftentimes we call that little a. The central angle is an angle that has a center right here at the vertex is at the center, and it goes to each corner like that. So basically a hexagon has 6 central angles. So that's how you make a central angle right there, and we should be able to calculate how big a central angle is. You know, for instance, if I wanted to figure out how many degrees that is right there, how could I do that? (360) divided by 6, because a full circle is 360 degrees, and basically we have 1, 2, 3, 4, 5, 6 pieces, kind of like a pizza in 6 slices. So if I divide this one by 6, this would be 60 degrees. And that's going to become a very important number because we're going to have to do trigonometry to find out how long sides are. I got a little octagon problem from the UFC I'm going to put up here in a second that we looked at this morning. Did some Googling. So that's called a central angle. And then here's where it says how you can find the central angle. You just do 360 divided by how many sides there are. Now, overall area. Before I just kind of say, hey, here's the formula. If I wanted to, I don't need to learn a new formula. If I could find the area of one of these triangles, what could I do to get the whole thing? What's that? What do you mean fill it in? No, I mean, what if I could find, so I'm going to erase this for a second. What if I could find out that for some, whatever shape this is, let's say that I knew that this side was 10 and that this little height in there was 8. Could you find the area of that hexagon? What would you punch in? Come on, Tessier, you said fill it in. I'm about to fill it in. What's the area of that triangle? What's the area formula for any triangle? Good. So area of a triangle is half base times height. So what's the base of this triangle? Well, the base is 10. Okay. You sure? Why did I put 50 in there? I don't know. So half of 10 times 8, which Mitchell's back there saying 40. Shout out to Mitchell Doom, being a knucklehead. Kids for years are going to hear this now. Alright, so that's 40, you know, centimeters, inches, whatever it is. Well, now how would I take that and get the rest of the shape? Exactly. So basically I have 6 triangles. 6 of these 1/2 10 times 8s. Now, there's a way to speed this thing up because every triangle is going to have the exact same height and the exact same base. So how this formula works is it adds up all these bases in the beginning and calls that the what? What is it when you add all the way around a shape? It's perimeter. So instead of doing triangles separately, they find the perimeter and then multiply it by this apothem and they come up with a formula. Now, I got kind of a funny way of how I memorize this formula. Hopefully Mr. Gill doesn't hear this video. But when somebody says, hey, what's the formula to a regular polygon, I say it's like a little dwarf Mr. Gill. Like I always picture Mr. Gill, like imagine him about this big, kind of just like all stocky. Because the formula is 1/2 AP, and he's the assistant principal, so I don't know, I always think of that. So if you want to just plug and chug, this is the apothem, and this is the perimeter. So you really don't need to do the whole triangle thing. You can just stick it in the general formula to find all of it at once. Now the tough part is we are usually going to be missing a side or a height of that triangle, the apothem, and we need to use trig to get it, or Pythagorean theorem. Now these are really easy. So let's just bust out a couple easy examples. These are plug and chugs. So area 1/2 Mr. Gill, and I just now got to do a little baby calculation. So what goes here? The apothem, the kind of radius, so to speak. And then what would be the perimeter of this shape? I don't want to put 12 in there. You know, you got to do a little bit of work to get this guy. It'd be 12 times 8 sides. You know, 1, 2, 3, 4, 5, 6, 7, 8. So what's that, 96? And then we got to jam that in our calculator. And we get 0.5 times 14.5 times 96. Oh, this must have been where I stopped this morning. 696. And then it's just units squared, whatever the units are. Yeah, I did 0.5. 0.5 times 14.5 times 96. All right. So you guys try the next one real quick. See if you can crank it out. So I'm hearing from the crowd that it's 95.625. So we have 1/2, we have the apothem, and then the perimeter was 7.5 times by 5 because this is a pentagon. And when I put that answer in here, we end up getting 95.625. I like it. All right, so we're going to go off script. This is off the video notes, but whatever. It's entertaining. UFC. The Octagon. Whew. See if you guys can, I know it, I'm scared. So there's the Octagon at the UFC. The dimensions are, this is going to be kind of a tough problem for you. See if you can get it. The dimensions all the way across the Octagon are 30 feet. It's 30 feet across from wall to wall. And the area is 750 square feet. This room's about 32 by 32. This room's close to 1,000 square foot. So an octagon's, you know, about 3/4 of this room. So my question is, if you wanted to build one of these in your backyard, there's actually one in Battle Creek when you're coming into town, and somebody build like a kind of a half slapped together octagon. It's all kind of falling down now, but on Michigan Ave, Battle Creek. So how could I find this? How could I figure out how long to make the wall with that information? Mitchell? So hold on, what's 15? This or the apothem? Okay. So it's 15. Well, how do you know who to just start dividing by? So key is start with the generic equation. Start with the big structure. Fill in what we know. We know area is 750. We know the apothem is 15. It's halfway across that thing. But we don't know capital P. So I crank this out and I get 750 equals 7.5 P. Yeah. Why 8? Well, but 750 means there's 750 one by one. Like if I had a tile from Home Depot and I wanted to make the thing out of tile on the floor so it'd be even harder when we slam somebody, I'd have 750 tiles on the floor. So I don't think it has anything to do with the sides. So I divide it out and I get 100. And if the perimeter is 100, that's all the way around, then I think I can do what you're talking about, Belor. To find one side, I do what with that perimeter? Divide it by 8, because there's 8 walls. And that comes out to be 12, roughly 12.5. Now I think the real octagon, it was a little tiny bit different than that. So in the octagon, your walls are about 12.5 feet, roughly, all the way around. So that would be like a mid-grade problem. We didn't need trig, we didn't need Pythagorean theorem, but we did have to work backwards because we were given the final answer. So be prepared to be able to do that. All right, let's jump into some. We're back on script. Get all excited. Want to do some other things. All right, so here are some options. It says sometimes you're missing something. You need to use trig or special right triangle stuff. Sometimes you only have a side length. Sometimes you only have the apothem. And sometimes you only have a spoke, which I don't know why we called that radius, but a spoke, let me just kind of talk about that for a quick second. Whenever I use the word spoke, it goes from here to the corner. So that's the spoke. This is the apothem. All right, so make sure that you don't take the apothem to the wrong spot. All right, so let's go up and let's look at some of these examples, and they get a little bit hairy. So if we only have a side length, we want to find the area of this thing. So always, somewhere you should have your general formula, 1/2 Mr. Gill. And I need something. I need one of those two. So which one of the two letters can I get right away? I think I can get the perimeter, because if this is 16, I just multiply it by 6. 6/16, the perimeter is going to be 96. But now's where it starts to get interesting, because now's where I have to go on a little bit of a goose chase. A is going to be tough. It's going to involve a lot of scratch work. So let's think about this. And for me, I always like to operate on the triangle on the bottom just because it sits nice. I could draw the triangle up top, but for me, it just looks easier in my eyes to make this triangle. Now, here's where we got a lot to do. Ultimately, this is A, and this is what I need to find. So where can I go from this point? So I only have one side of the triangle, so I'm in a bit of a pickle right now. I do know this. This is helpful. I do know that this gets broken up into two separate little triangles, a right side and a left side. For whatever reason, I always deal with the right side just because it looks easier to me. So this is what I have right now. I need this A. This is what we're after. And I know this. And this isn't really enough to solve the triangle yet. But I need to get something else. Couch? These two sides? Yeah, and my big thing is I need to get an angle in there. Before I do trig, I have to get an angle either here or here. Rosetto? Well, take a stab at it. What do you think? So that is a 90 for sure. So they got to add up to 90, but they're not going to be the same each. Josie?
Well, it's a six-sided polygon, so 360 divided by 6 equals 60.
So you know that this top angle was 60, and if you split that in half, that means this is 30 up here, right? So now, if you want to get this angle, you can use that. You could play the trig game right now. You also know that this is 60, and you really have two options. So here are your two options from here. The lightning fast way, the very best way, would be to use your special right triangle rules. Special right triangle rules in the 30, 60, 90 say this is the baby. So how can you figure out the freak if you know the baby? Baby square root of 3. So I know right now that A is 8 radical 3. And I can solve the problem. But a lot of people aren't comfortable with the special right triangle stuff. So if you're not, just go into SOHCAHTOA world. You know, go back to here and say, hey, I'm going to put my guy at 30 degrees and I'm going to use SOHCAHTOA. And this is opposite and this is adjacent. So that would be a job for tangent. Tangent of 30 degrees is opposite over adjacent. Now, some of you guys are law of sines lovers. Some of you, you know, you get this 60 and you could play the across from game with the law of sines. Some people go sine of 30 is 8, and then the sine of 60 is A. The nice thing about the law of sines is you don't have to know to use tan or cos or sine, but it is more work. Now, the last thing here is if A is on the bottom, what do you got to do? X is high, you multiply. If it's low, you got to trade places. Now, you will find that this 8 divided by the tan of 30 should come out to be the same exact decimal as 8 radical 3. It's just if you know your special right triangles, it's like a 5-second problem. You don't have to go through the trig crap. Now, I don't know what that comes out to be. Did anybody crank it out? Let's punch it in. 0.5 times 8 times radical 3. Get out of there. Times 96. 665? Now I was a little worried because I'm like, well crap, that's a bigger wall than the octagon and this is smaller. I did something wrong. But this isn't an octagon, this is a hexagon. So it's a totally different shape. Alright. Now this idea right here that I just did, this is going to be needed on every single hard problem we have. The only thing that they're going to change is when Josie did this problem, with different shapes, you're going to have different numbers right here. So this is kind of why we had to learn all the different shapes early on. So let's check out this one. And I'm going to just kind of do this one more instead of asking for help. So this one I'm only giving the apothem. I know that this line is 3. And I start off my formula. I know A, but I'm missing P. So the whole game is going to be, let's go on a goose chase to get P. Well, I got to draw my triangle. Now a lot of times I don't even draw the full triangle. I just draw this side of it. And there's lots of ways to do these. I'm going to show you another way on this one. You know, Josie, she kind of did this method, which starts from the central angle and works itself out. You know, so on this one I'd have 360 divided by 8. So I think that goes in there 45. So every one of these is 45 degrees. So what I could do is I could get my little triangle here. I know this is 3. 45 degrees isn't here, it's the whole thing. So I need to split it in half. 22.5. And what would really help me out is if I need to get this value, because that'll be this side. I can double it, get the whole thing, and then find the perimeter. So I'm going to put my dude here. I'm going to stand right there. You guys going? Oh, good luck. Go kick some butt. So I'm going to stand there, and if I need this, I'm going to just call it X. You too. You're pretty much always going to use tangent if you want to, if you're up here at this top angle and do like Josie did. So I'm going to go the tangent at 22.5 equals something over 3. Now on this problem, what am I going to do to both sides to find out what X is? When X is high, I got to multiply. So I times by 3, times by 3, and I'm going to punch this in the calculator. 3 tan 22.5 equal, I get about 1.24. I'm going to just keep 2 decimals. I think that'll be enough. Now, we still have 2 minor things to do. What I've really just found was this little half is 1.24. So, because I was kind of focused in, just in this triangle was really this triangle. So I need the other side to get the true side length, which is 2.48 when I double that. And now we can finally get the perimeter. The perimeter is 2.48 multiplied by, this sucker has 8 sides, 19.84. Now, when you guys are doing the test or the quiz, make sure to show me this work, because if you do some good stuff, but you make a math error somewhere, it'll be easy for me to say, oh man, you forgot to double the 1.24. That's going to happen. There's going to be kids that take 1.24 and multiply it by 8 and get the wrong perimeter, but I can give them most of the points. But if you just write down the answer, you get nothing. Yes, sir. Okay, so you're saying maybe I should have kept on instead of rounding. I'd have been a little more accurate. Let's just check the difference at the end of the day. 0.5 times 3 times 19.84. So I would have got 29.76 as opposed to, if I'd have kept it a little bit better, so it is a little bit off. If we rounded the nearest tenth, we'd both probably agree on 29.8, but I don't think there'll ever be a multiple choice test that will have answers that close. They'll be spread out quite a bit further. All right, last one. We got time. Crank this sucker out. So given only the radius or the spoke, and I apologize because I referred earlier in the notes to the radius as being similar to the apothem. Which probably shows about how important that is, because if I don't remember it, at the end of the day, I don't think it's that big a deal. But if they give you the radius, that's going to be from there to the corner. So we have that going on, and let's say that they tell me that this thing is 12. So the top example, they give me the apothem. One of them they give me a side. This one they give me a spoke. I should still be able to crank this thing out. Now I'm going to show you a little bit different way than the way Josie did it last time. Sometimes it's easier for me to find this angle, because to be honest, I already have them memorized. Does anybody remember from earlier in the chapter how many degrees were in a pentagon? Yeah, it was 540. Hexagons are 120. Pentagons were 108. 108 and 72. So if you can remember that, if you can remember the 108, you could use that, because if these dudes are all 108, this one down here gets split in half, and I can steal 54 from it. Okay. Now, Josie's way would have been great because I could have did 360 divided by 5, which would have been 72. And then when I chopped 72 and a half, I would have got 36. So you could do it either way. It doesn't matter. It depends on where you want to stand. Maybe this way's better just because you do it the same every time. Doesn't really matter. But I got to get after this thing. So I got area, 1/2, apothem, perimeter. Unfortunately, I don't have much to fill in. I'm kind of broke as a joke right now. I got neither number. So this is by far the hardest scenario. So let's go into our little triangle world and start getting some things. Let's just do that so we don't have too many angles to have to deal with. Well, I need the apothem, and I also need this to get perimeter. So this is like a 2-for-1 special. And I would just do trig twice. So let's go after, let's get the apothem first. If I put my dude on 36, I know the adjacent and I know the hypotenuse, so that sounds like a job for cosine. Cosine is adjacent over hypotenuse. And then if I want this dude, he's opposite in hypotenuse. So I can run it back and do the sine to get opposite over hypotenuse. And I'm going to get a couple answers from those two equations. A is high or x is high, I'm going to multiply. So I'm going to do 12 cos 36. Over here I'm going to do 12 sine 36. Kind of try to kill two birds with one stone. That's 9.7 roughly. This is, we'll just call it 7.1 if I round up. So I know my A, that's this one, so I can just jam that in the formula. I'm getting close to being able to plug and chug. And now this is not P, don't put it up there, because we still got a little ways to go. That was simply just this little part right here. But then I got to do the other one for a side length of 14.2. But that's only one side, so I need to then times that number by 5 to get the entire perimeter, which would be what, 71, I think? Now we can come up here in this plug and chug time. So 0.5 times 9.7 times 71 equals, I'm getting a grand total if I didn't screw this up, 344.35. And that wraps up these video notes.